Hello everyone. Today we're going to be learning about KVL and KCL. So KVL, or Kirchhoff's voltage law, states that the sum of voltages around any loop in a circuit is zero. So for example, if we have a circuit with a voltage source and two series resistors, R1 and R2, KVL states that Vs plus VR1 plus VR2 equals zero, where VR1 and VR2 are simply the voltage drops across each resistor. Now, one key thing you need to understand is why the voltage drops across the resistors are negative and why the voltage supplied by the voltage source is positive. So, think of these resistors like hills, where the top of the hill is the positive or the higher potential terminal, and the bottom of the hill is the negative terminal or the lower potential terminal. And think of the conventional current flowing through the resistor as a boulder. So the boulder starts at the top of the hill and rolls all the way down to the bottom. So how does this relate to circuits? Well, if we look at our Vs, conventional current's going to come out of the positive terminal and run into VR1 or resistor 1. And it's going to keep going through R2, where it's going to go from a higher potential each time down to a lower potential. This gives resistors a voltage drop, whereas the voltage source is going to give a voltage rise in Vs, thus giving Vs a positive sign and VR1 a negative sign. So if we add VR1 and VR2 to the right-hand side, we get Vs equals VR1 plus VR2. Okay? Now KCL, or Kirchhoff's current law, states that the sum of currents in or out of any node is zero. So if we have a node here with currents going out like this, and this, and we'll label that I1, I2, and I3. And then we've got current going into the node IT. KCL states that IT equals I1 plus I2 plus I3. Okay, let's work on a couple of examples. Okay, this first one being a KVL example. And we're being asked to find the current supplied by the voltage source, I source, and the voltage drop across each resistor. So I source is the conventional current coming out of the voltage source, the positive terminal. I'm going to label it as IS. VR1 is the voltage drop across R1, VR2, the drop across R2, and VR3 is R3. So we know from KVL in our previous discussion, 5 equals VR1 plus VR2 plus VR3. Now, we know from Ohm's law, V equals IR, right? And since these resistors are in series, they're all going to share the same current, which is IS. So we can plug in IS times R1 for VR1. We can plug in IS R2 for VR2, and we can plug in IS R3 for VR3. Now we've got 5 equals ISR1 plus ISR2 plus ISR3. Factor out an IS, we get IS times the sum of the three resistors equals 5. If we sum these all up, we get 220. So I source equals 5 over 220 amps. All right, so now we just need to find the voltage drop across each resistor. So again, using Ohm's law, we know VR1 equals ISR1. We know VR2 equals ISR2. We know VR3 equals ISR3. We plug in IS for each one and multiply by the resistor. We get VR1 equals 500 over 220, which is roughly 2.27 volts. Okay, VR2 equals 100 over 220, which is roughly 0.45. And then VR3, again, equals 500 over 220, or 2.27 volts. Now, you'll notice if you sum all these up, they all equal roughly 5 volts. So this is a good way to check your answers after you get values, just to make sure, hey, I did actually do that right. All right, let's move on to a KCL example here. We're being asked to find the voltage at node A. So we've got node A here. We've got current going out and to the right through R2. We got current going out and to the left through R1. We got current going down here. Now, I like to draw all my nodes like this with all the currents going out, and then I just assign the signs based on that. So if we look at the current going down, you'll notice, hey, this is a current source that's pushing current up into the node, right? All that means is we're going to assign this to -1/2 amp. Then the current going to the right, from Ohm's law, it's going to be VA minus 3 volts over 1,000. The current going to the left is going to be VA minus 2 over 1,000. So if we write this down, we've got VA minus 2 over 1,000 plus VA minus 3 over 1,000 minus 1/2 equals 0. Add 1/2 to both sides, we get 1/2 equals VA minus 2 over 1,000 plus VA minus 3 over 1,000. Multiply both sides by 1,000. Those cancel out, and we get 500 equals VA minus 2 plus VA minus 3. 505 equals 2 VA, or VA equals 505 over 2. Now, how do you error check this? Well, you simply plug this value for VA into your node equation. So 505 over 2 minus 2 divided by 1,000 is roughly 0.2505. And then 505 divided by 2 minus 3 all over 1,000 is roughly 0.2495. So if we plug those two values in here, we get 1/2 equals 0.2505 plus 0.2495, which gives us 1/2 equals 1/2, verifying our work here.